Determining the domain and range of a function using an algebraic and a graphical approach. We'll start with the graphical approach. The function that's given is called a rational function because we have the variable x in the numerator and the denominator. So if I were to use a graphing utility to graph this function, the picture would look like this. I can use the graph to determine the domain. The domain is all allowable x values. So when you look closely at your x-axis, you say, is there a place that the function will never be? Is there an x value that is not allowed? We can see that these places on the curve are called asymptotes. The curve will approach these lines but never quite reach it. The equations of these lines are x equals -4 and x equals 4. Therefore, my domain is any real number except -4 and 4 is allowed for x. Now the range are my allowable y values. You can see that this curve will head toward positive infinity and negative infinity. There's no there's no y value that this curve will not be associated with. So my range is all real numbers. Now typically it's the domain that we're most interested in. So let's solve this same problem, but without looking at the graph. We'll solve it algebraically. So when you look at your function, because it's rational, we don't want the denominator to be 0. So we can say x squared minus 16 is not equal to 0. We're not allowed to divide by 0. Here we'll factor that expression because it's the difference of perfect squares. Now we'll apply the zero product property. X plus 4 cannot equal 0 and x minus 4 cannot equal 0. Therefore, x cannot equal -4 and x cannot equal 4. And refresh your memory that that makes sense because when we graphed this, we noticed the graph doesn't go through -4 or 4 on the x-axis.